Okay, so here's our review section, section 6 from trigonometry. This portion of this video is only going to have the first page on it, and then we'll wrap this up on a second video. First off, probably a new word for many of you, a sinusoid. A sinusoid is just a sine curve, but it's also a cosine curve as well. There aren't cosinusoids. A sinusoid is just, because we know that a cosine curve is a sine curve, just shifted around. So it's just a name. I just want you to recognize it. Don't be intimidated by it. It just means it's a sine curve. And it's the ones that we typically worked with. We typically multiplied a times sine or cosine, and we might have had something times x in here, plus something to have a little shift to the right or left, change the amplitude. B makes things happen faster or slower. Like I've talked about, like accordion in, accordion out with our sine curve. And D just raises the curve up. Okay, A, B, C, D are real numbers. We're going to deal with that on the second portion of the second video, or tomorrow. Inverse sine function. Now, as soon as we say that, y equals sine of x, it looks like this, on and on and on and on. So, inverse sine function, well, the entire graph of y equals sine of x doesn't have an inverse function because it is not one-to-one. Therefore, we have to look for the one-to-one portion that contains all the possible things that sine can produce. We're going to stay close to 0 and we're going to go positive as far as we can on this. I can go to this point right here. And if I go beyond there, I'm no longer one-to-one. So I'm going to pick up my negative values by going backwards, so I'm right in here. That is between negative pi on 2 to pi on 2. So the domain of the sine function we're going to use is negative pi on 2 to pi on 2. The range is negative 1 to 1. Inverse functions. I guess this is a good time to talk about this. So here's my trig function right here. Any trig function. Plain old trig function, not inverse trig function. What do we put into trig functions? Sine of this thing, cosine of this thing, secant of this thing, cotangent. What is it that actually goes in there? Obviously it's a number, but what is that number? What is it? Is it the number of cats the old lady down the road owns? No, it's an angle measure, right? We put angle measures into trig functions. We put in angle measures. What comes out of them? Ratios of side lengths. Either opposites on hypotenuses, or adjacents on opposites, or y's on r's and x's on r's, and all that good stuff. Ratios come out. Okay, now, so inverse functions, if we put angle measures in and we get out ratios, if we put in angle measures and we get out ratios, what happens on inverse functions? We put in ratios and we get out angle measures, right? Either in radians or degrees, depending on how we set our calculator or how we're calculating that. Okay, now, if sine of x has a domain of negative pi on 2 to pi on 2 and a range of negative 1 to 1, if that's what we're looking at for our inverse function, take a look. The inverse function, I'm going to use sine negative 1 of x almost exclusively, but arc sine, same, has a domain of negative 1 to 1, where this had a range of negative 1 to 1, and a range of negative pi on 2, where plain old sine had a domain of. And you should say, what a coincidence. No, you shouldn't say what a coincidence. You should say it has to be that way. Because on the very base level, what do inverse functions do? They turn x's into y's. So domains get turned into ranges because domains were the x's. That should make perfect sense, I hope, if I explained it well. If not, watch the video. All right? Cosine. Here's our cosine graph. We all know the looks of this thing. It goes on and on forever. So it's not 1 to 1. So we start at 0 and we start moving until it's not 1 to 1 anymore. We can move all the way over to here. From here to there. So on cosine, we're 1 to 1 from 0 to pi. That's our domain that's going to be used for inverse cosine. So inverse cosine has a range of 0 to pi. We're still range of cosine negative 1 to 1, so domain negative 1 to 1. You'll see why that becomes important to us. Okay, tangent. I'm going to put that off to the side here. Here's tangent between negative pi on 2 and pi on 2, and then on the other side of pi on 2, asymptote does this again and does this again over here. But we've got a nice defined part of the curve right between it. Covers the 1 to 1 portion between negative pi on 2 and pi on 2. So if I'm going to use negative pi on 2 to pi on 2, tangent inverse is going to return values in its range negative pi on 2 to pi on 2. But the range of tangent, negative infinity to 1 infinity, becomes the domain of... So that's telling me I don't mind having things like tangent inverse of 740. But this is telling me I don't like having sine inverses of 740. Right? Sine inverse can't handle negative or 740. Okay, I want to jump down right now to example 2, and then we'll come back up to example 1. Give measure of angles in radians and degrees. Give the exact values whenever possible. Okay, what goes into inverse trig functions? Ratios. So guess what the first thing I'm going to do here is? I'm going to make that be a ratio. And a ratio is just a fancy name for a fraction. What ratio goes into sine inverse? In SOHCAHTOA land, what inverse or what ratio goes in there? Opposite on hypotenuse, right? Well, opposite on hypotenuse is y on r. That's our y on r ratio. I want y on r to be 1 to 2. Sound like maybe that's a good triangle? 30, 60, 90 or 45, 45? Yeah, we got 30, 60, 90s that include a side of 1, 2, and root 3. Right? I just have to have the y be the short side and the r be the long side. So sine is positive 1/2 right here if this was a 30-degree angle. Where else is sine positive? Right here. 1, 2, 30 degrees. Where else is sine positive? Well, spin around the circle 360 and then add 30 at 390. And it's over and over infinite places where sine is 1/2. But we're only allowed to have one of those. But how easy is this? We just stay as close to 0 as we can. We can rotate forward, backward. We just stay as close to 0 as we can. So this is it. So we get either 30 degrees, which of course is 1, 2, 3, 4, 5, 6. 1/6 pi, or pi on 6. So we just picked the one that's closest to. Now I need to point this out. Inverse trig functions, if it's written like this, laser focus. If your problem starts written with the sine inverse or the tangent inverse or the cosine inverse in it, there is going to be one answer. Now, if it started out like this, I'm going to put it right over here. If it started out sine of x equals 0.5 instead, and we take the sine, we introduce the sine inverse on both sides, we might have an infinite number of solutions. But if it starts out sine inverse, there's one solution. So we might have to, for this one, we'd end up saying, oh, sine is 30 and 150 and 390 and multiple revolution thing that we've talked about before. One answer, though. One answer for this. Tangent inverse. Guess what I'm going to do first? I want ratios. What ratio is -5 to 1. In SOHCAHTOA land, opposite adjacent. Opposite adjacent, y on x. I want y on x to be either -5 on 1, or I want it to be 5 on -1. Does that sound like a 30-60-90 or a 45-45? Nope. I'm still going to draw it, though. At this point, we're going to go to our calculators, but I'm still going to draw it. Well, -5 on +1 would be x1 would be down here. +5 for y on -1 would be left and up. Would be this. Is that all right? Which one's our calculator going to give us? Let's go to degrees first. Let's put our calculator in degrees and let's do tangent inverse -5. Which one's it going to give us? The quadrant 2 answer or the quadrant 4 answer? Give me just to the nearest tenth. -78.7 degrees. It chose the one closest to 0. That's pretty easy to remember. Now, what if it's a tie? Let's say I could go first quadrant or fourth quadrant. Then we go with the positive. Okay, that would be the case with cosine. We go with the positive if it's a tie. But otherwise, we go closest. Now, we got two avenues to turn this into radians. We either just put our calculator's mode back to radians and find tangent inverse again, or we cancel degrees by multiplying by pi and dividing by 180. Give me our radian measure to, let's go 3 decimals, just for the sake of it. Let's go 3. 373. Is that all right? We good there? Okay. I do want to come back and talk about these. We're supposed to find an arc length. Oh man, an arc length. It's been a while. I forgot that formula. I remember there was a formula for it. At least that's good. That's my memory. But I forgot what the formula was. Okay, so I need part of a circle, an arc. Radius 2, I'm just going to put it here. And it says 5/8 pi. I'm going to try to draw this close. So this would be 8/8 pi around to there. So 4/8 to there, 5/8 somewhere in here. This is 5/8 pi. And this is my arc length. I remember that we named those S. And there's some formula about the radius and the arc length and the angle measure, but I forget what it is. But an arc length is just part of what? The circumference. And I remember that one. Circumference is 2 pi r. Now, a good mathematical way of saying part of is a fraction of. What fraction of the circumference are we dealing with? 5/8 pi out of 2 pi, right? Or our arc length equals the fraction, that's our angle, out of 2 pi, that's the fraction, of the circumference. Oh, that's our formula. S equals theta times r. All right, this is the biggie. Must be radians. Does not work if theta is not radians, but that's our formula. So our arc length here on example 1, S equals our arc length, or S is our arc length, so it equals our angle measure, 5/8 pi times our radius, 2. So that is 5/4 pi. Is that okay? Everybody see what just happened there with that S equals theta r? How many of you remembered it's S equals theta r? Raise your hands. Let it be known that that is 0. How many remember circumference is 2 pi r? That is at least most. Okay. So now I've got this. S equals theta r, so my arc length 3 pi equals my angle pi on 6 times r. My radius unknown. Multiply 6, 18 pi, divide pi, 18. R is 18. Okay. So we will pick up the rest of this on tomorrow or on the next video. We'll wrap up the rest of our section 6, and that is the last section of the chapter. We'll be looking at testing midweek next week.